So looking at number 1 from the FRQs. Again, we'll do 1 and 5 together, and then you'll do 2 and 6 on your own. Okay, so there's g of x. Thank you. All right, so my calculator looks like the picture they gave me, so I feel pretty good about, at least I've got things in the calculator the right way. All right, find the sum of the areas of regions R and S. So how do I find the area of R?
Sum, top minus bottom, integral.
Yeah, integral, top minus bottom. Okay, now this is where it matters who comes first. So the way I've got them labeled, top minus bottom in R would be G minus F. From what to what?
0 to wherever that intersection is.
Wherever the intersection is.
0 to wherever the intersection is. So I'm going to call it 0 to A. And then say A is the intersection of F and G. And then my calculator can find that. Second calc, intersection, first curve, second curve. It's not 1. Close enough to trick you into thinking it's 1, but far enough away to get the wrong answer if you just use 1. 1.0328 ... But I'm going to store that as A.
Equals A.
Because I bet we have to use it again. So exit, store as A, 1.0328. Yeah, so we're good. Okay, so now I'm ready for region R. Region S would be A to 2. Top minus bottom, but they flipped, so F minus G dx. And I'm trying to think how much work I want to show. I don't really need to show much more. I can just say R plus S equals and give the answer. So 0 to A. Be careful about who's G and who's F here. So y2 minus y1. Be region R. I'm just going to hit enter because if I get a negative number, that means I did something wrong. So I'm going to look and see what my answer is just to see if, at least it's not negative. Plus math 9, A to 2 of the other way around, y minus or y1 minus y2 this time. Dx, and that one should be positive as well. So R plus S 2.004. Yeah. Again, that's all the work that I have to show. I don't have to rewrite G and F. No, the grader knows what F and G are, so don't rewrite all of that stuff and risk messing something up.
Would it be worth
Use the
it
symbols.
putting R and S equal? Do you think they would put?
You mean to show the steps that R equals 0.997 and S equals whatever the other one was?
1.007.
I don't think it would help you. It wouldn't hurt. And if it helps you sort of keep straight things, then that's not a bad idea.
Keep straight things.
Keep things straight.
My brain went syntax.
Question B. Region S, part B. Region S is the base of a solid whose cross sections perpendicular to the x-axis are squares. I submit they made that about as easy as of a cross-section problem as you can get. So we only want region S.
The integral, or?
It's definitely the integral.
The integral of s squared, but I'm not quite sure what s is.
Yeah, careful with s because we don't mean uppercase s.
Lowercase s.
The integral of s squared, because that's the area of a square.
From a to...
From a to 2, dx.
Or would it be ds?
No, dx, because we're slicing dx.
Okay.
But what is x? What is, or s, excuse me, what is the length of that side?
F minus g?
F minus g, top minus bottom. And I think that would be enough to get you full credit if once you did that, you'd got the answer. But that's not quite calculator ready, so I'd probably do one more step just to make sure I knew what was going on. Like that. So, what about pi? Do I need pi in this thing?
No.
No, that's only for a rotation or a circle. It's a square. Some people get so used to throwing pi's on their volume that they put them in there when they don't need them. So from a to 2, parentheses, f
y1 minus y2.
was y1, so y1 minus y2, close parentheses squared, dx. A to 2, y1 minus y2, got the squared in the right spot, dx. 1.283. Oops, not supposed to box things. Old habits. Okay. Again, reread the question, make sure it's...
There's no units.
Region S, the base of a solid, cross sections perpendicular to the x-axis, squares, find the volume. Yeah, so no units, no explanations.
No touchy.
We're good. Part C. Let h be the vertical distance between the graphs of f and g in region S. So, vertical distance between f and g in region S.
That sounds like a derivative because it says rate in there.
Yeah, but before we get to the rate, that does mean derivative.
I'm just trying to start somewhere.
Find the rate at which h changes with respect to x when x equals 1.8. Okay, so yes, what they're looking for is dh dx when x equals 1.8. But what the heck is h?
F minus g.
Yeah, the vertical distance is just the top minus the bottom. So f minus g. So this is if you make that connection, this is an easy problem because h prime or dh dx is just f prime minus g prime. So h prime at 1.8 is f prime at 1.8 minus g prime at 1.8. So that key step there was recognizing that they described this strangely, but vertical distance is just top minus bottom. When they say rate of change, that's a derivative. So this one is, I guess it's just testing that you understood the vocabulary as much as anything. Okay, so y1 is f, so math 8 is the derivatives. So derivative of y1 at 1.8 minus, minus math 8 again, the derivative of y2 at 1.8. And again, it's a calculator problem. They know it's a calculator problem. They're not expecting you to take derivatives of this stuff by hand. Like, they know you have a calculator. Use it. Like, clearly, they're just testing some vocabulary on this one. Negative 3.812. Let's see if that makes sense.
Because
1.8.
it's getting smaller.
Yes, exactly. That distance over here at 1.8,
It's getting smaller.
as we move left to right, is getting smaller. I can just tell by looking that vertical distance is. That vertical distance right there is getting smaller. So it makes sense that it's negative. So we did that one in 10 minutes. Or maybe a little more than that because I didn't hit record at the beginning.
It was only by like 30 seconds.
That one was pretty straightforward.
Yeah.
Number 2 is for you to do. Again, the equations are weird, but who cares about weird equations because you have a calculator. And they gave you a little bit of a bonus here by telling you who's who. We'll probably do that one tomorrow after you try it. So let's fast forward to number 5. No calculator. Let R be the shaded region bounded by the graphs of y equals x e to the x squared. Well, may I humbly admit that I would have no idea what that looks like, but based on my options over there,
Looks like the curve.
it's got to be the curved one. Y equals negative 2x. I know what a line with a negative slope looks like. I'm going to call that y2. Vertical line x equals 1. Put my calculator down because I can't use it. Find the area of R.
That's
All right,
area under
this
the curve.
is same thing. Top minus bottom from left to right. So that would be from 0 to 1.
Yeah.
The top curve is y1. But I'm not just going to stick y1 in there because I have to do this by hand, so I may as well put x e to the x squared minus negative 2x.
So plus 2.
So plus 2x. So x e to the x squared plus 2x dx. Okay. Integrating 2x is easy. Integrating x e to the x squared.
It's a little harder. Could we use sub this?
We could definitely use sub this. What would be a good candidate for you?
E to the x squared.
If- Yeah, just x squared. If you pick e to the x squared, then du is going to be e to the x squared times 2x, and you're going to have a mess. So du is 2x, which is good. Oh, whoa, careful on the putting 1/2 out front, because I don't want the 1/2 to go to everybody. So I'm going to go ahead and split this up. 1/2 e to the u du plus 0 to 1 2x dx. So be careful putting the 1/2 out front. That almost got us there.
Goes over.
Oh, this isn't quite right. Actually, it is. It turns out it is right. The limits. We didn't change the limits to u limits.
Oh.
They were super kind on this one. Those are my x limits.
Yes.
If I change them to u limits,
Oh, they're the same thing.
they're the same thing.
Okay.
So we'll officially change them to u limits, but it didn't really matter. I feel like I could be skipping more steps than I am here, but that's okay. All right, the antiderivative of e to the u is e to the u.
U e to the u or?
Nope, just e to the u. From 0 to 1, put the 1/2 out there. Antiderivative of x squared of 2x is x squared from 0 to 1. So 1/2 e to the first minus e to the 0. Be careful, a lot of times we just throw off the bottom if it's 0, but you can't do that here because e to the 0 isn't 0, e to the 0 is 1. Plus 1 minus 0. That could be simplified,
Oh, to e over 2.
but why bother? E over 2 minus 1/2 plus 1. I really wouldn't even do this, even out to the side, because if you make a mistake,
Then they'll count
it's
that
like,
off.
not really. I didn't really do that. Don't look at that.
You were just curious.
That was just my own, yeah. There's my area. I don't want to mess that up.
Ew.
Go back and read the question when you're done with it to make sure you didn't leave off any explanations or units or anything. But that one just said find the area. So done. Found the area. Write but do not evaluate.
Love that.
That's good news, bad news, right? The good news is you don't have to evaluate. The bad news is it must be ugly if they don't expect you to evaluate it.
So it's rotated about.
An integral expression that gives the volume of the solid generated when R is rotated about y equals -2. Okay, well, if we plug in 1, we get -2, so we're going to rotate around that spot right there.
We have to washer it.
Definitely washers.
Ugly.
I mean, just writing washers isn't going to get you any credit, but at least it gets your brain headed the right way. What might get you credit, though, is pi times big R squared minus little r squared. 0 to 1 dx. A lot of times you get a point for sort of like the correct format and the correct limits. And so it's likely, I'd even say probable, that you get a point if you just have that much. We got to figure out what R is in little r, but we're at least on the right track here. So big R is from the outside radius, or the outermost, to the axis of rotation. So there's big R.
-2 minus y1?
I would say it the opposite way. I'd say it's top minus bottom. So y1 plus 2. Because it's y1 minus -2, top minus bottom.
Little r is.
Little r is the inside radius. So that is y2 minus -2. y2 plus 2.
Here we go. No touchy.
I don't know if that would be enough or not.
Or no, I plugged it in.
Yeah, I think you would need to plug it in. 0 to 1. If I defined y1, then I should be okay to just leave that as y1 plus 2 squared minus y2 plus 2 squared dx.
There we go, no touchy.
Makes me nervous. I think I would probably fill in the a semester's worth of college credits on the line here. If it takes 10 extra seconds to clearly communicate what I'm trying to say, then it's worth it. I also recognize that if you had gotten these backwards, you squared it, it would have fixed it. So I think they would have to accept the answer if you said this was -2 minus y and -2 minus y2. because the squaring would fix the sign and you'd end up okay anyway.
You could argue with them and be like, "Hey."
Let's see. Write but do not evaluate. Integral expression. Yes. No units. No explanations. We're good. Part C. Write but do not evaluate again. An expression involving one or more integrals that gives the perimeter of R. We can omit that because we didn't do distance. We don't do distance.
Oh, okay.
Yeah,
Is
distance
it a VC
is it's a VC thing.
Yay.
Something. It has to do with Pythagorean theorem, but we're not worried about it.
We no touch.
Yeah, threw out one of those that had a perimeter, but I didn't catch that one. All right, so your job is number 2 and number 6. And this thing is not due until April 28th. Your video this week is video number
5. Right?
5 because they match up still?
Yeah.
Yep. Video number
Write
5.
that on the board.
Video number 5. Oh, yeah, it's up there, but I need to fix that.